Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration with partial fractions of the integration series, and I encourage you to check out all the other parts prior to this. And remember to subscribe so that you don't miss out on any of our future uploads. It could be either in the integration series or any other topic. Diving into today's business, we will use the integration and partial fractions concepts collectively. But prior to this video, I encourage you to check out our videos on partial fractions, definite integration, part 5, integration of exponential, part 10, integration with natural logarithms, these are part 11 and part 16, integration of trig functions, these are part 12 and part 13, and lastly, the integration of the arctan, part 15. Well, just as a bonus, integration by substitution, part 17 and 18. In summary, our integration series. Great, so now let's look at example 1. Find the integral of x squared plus 2x minus 5 divided by x minus 3 times x squared plus 1 dx. So the solution. Let's consider the fraction inside the integral, and recall from our partial fractions video, this is a proper algebraic fraction with a quadratic factor that cannot be factorized. Therefore, it can be expressed as follows: x squared plus 2x minus 5 over x minus 3 times x squared plus 1 is equivalent to capital letter A divided by x minus 3 plus bx plus c divided by x squared plus 1. We move on to clear the fractions according to our method in the video by multiplying both sides by x minus 3 times x squared plus 1 in order to get x squared plus 2x minus 5 is equivalent to a times x squared plus 1 plus bx plus c times x minus 3. We label this equation star for ease of reference. Great. So on the left hand side, we have the question and the key points. So we got equation star that we are going to refer to later on. Continuing that, we are trying to solve for A, B, and C. So the first thing we do here is eliminate by using the elimination method. So we are going to eliminate B and C by setting x is equals to 3. In so doing, we eliminate B and C, and we get 3 squared plus 2 times 3 minus 5 is equal to A times 3 squared plus 1. Simplifying that further, we get 10 is equal to 10a, implying that a is equal to 1. We move on to eliminate b by setting x is equals to 0 because 0 is directly multiplying. In fact, x is directly multiplying b, so setting it to 0 eliminates b in identity star. In doing so, we are going to get minus 5 is equals to 1 times 0 squared plus 1 plus c times 0 minus 3. Simplifying that, we would get minus 5 is equals to 1 minus 3c, meaning that our answer then becomes c is equal to 2. Now, we set an arbitrary value in identity star, which is not 3 nor 0, because in so doing, we would go back to finding the values we obtained for A or for C. So we just choose any other value. For instance, we choose x is equals to 1 and substitute it into identity star. In such a case, we are going to have 1 squared plus 2 times 1 minus 5 is equals to 1 times 1 squared plus 1 plus b times 1 plus 2 all multiplied by 1 minus 3. Then simplified, we would get minus 2 is equals to 2 minus 2b minus 4. So that we get 0 is equals to minus 2b, implying that b is equals to 0. Great, then so this implies then that our fraction that was inside the integral is equivalent to 1 over x minus 3 plus 2 over x squared plus 1. As we continue then in the integration step, what it means then is that we are going to separate these fractions and integrate them. And you would recall also from the integration with the natural logarithms videos part 11 and part 16, as well as the arctan video, we have this scenario over here. So that would give us the natural log of the modulus of x minus 3 plus 2 times the arctan of x plus c. And I encourage you to check this video out. Great, then we move on to example 2. So with example 2, we have evaluate the integral from 1 to 2 of 4x squared plus 2x minus 5 all divided by x plus 1 times 2x minus 1 dx. For the solution, recall the given algebraic fraction is an improper from the partial fractions video. Therefore, to express it as a proper fraction, we need to divide it first. Now check out our polynomial division video list. We start by expanding the denominator in such a way that we have 2x squared plus x minus 1. Then we divide using the long division method. And I encourage you once again to check out our long division method so that you have an idea of the approach we are using. Then in this case, we have the divisor and the dividend. So we consider the leading term in the divisor. That's the one that will be divided into each and every term in the dividend where possible. And in this case, it's only possible once. So we are saying that 4x squared divided by 2x squared will give us a 2. Then we multiply that 2 with every other term in the divisor so that we get 4x squared plus 2x minus 2. We subtract that from the dividend so that we get the final minus 3, which is the remainder. The quotient here is the 2. This then means that we can express our fraction in this particular manner. That is equals to 2 minus 3 over x plus 1 times 2x minus 1, and we label this equation 1. Now, considering the fraction in 1, we can also partition this fraction into 2 fractions. And I encourage you to check out our partial fractions video to see how we go about some of these things, because in this video, we are not going to cover step by step of each and everything we're doing here. Right, so we can express that fraction as minus 3 over x plus 1 times 2x minus 1 being equivalent to a divided by x plus 1 plus b divided by 2x minus 1. And clearing the fractions by multiplying both sides by the denominator of what we have on the left hand side, we would get minus 3 is equivalent to a times 2x minus 1 plus b times x plus 1, and we label this identity star. This one is an identity. That's why we have the 3 lines there, in case you might be wondering. Now, continuing, on the left-hand side, we have the question and the key points. So we are going to make use of this identity star. That's why we kept it under the key point of the solution. And then we want to eliminate a by setting x is equals to half in identity star. In so doing, we are going to get minus 3 is equals to b times half plus 1. Simplifying further, we have minus 3 is equals to 3 over 2b, implying that b is equal to minus 2. We eliminate b by setting x is equals to minus 1 in identity star once again, so that we have minus 3 is equals to a times 2 times minus 1 minus 1. And simplifying further, we are going to have minus 3 is equals to minus 3a. Then a is equals to 1. Therefore, we are saying that the fraction that we had is equivalent to 1 over x plus 1 minus 2 over 2x minus 1. Now that we have the fraction inside the integral, we now have it on the key points on our left-hand side and labeling it as equation, or rather identity 2. Then this implies that problem that we are trying to solve can actually be partitioned into this. So the integral from 1 to 2 of 2 plus 1 over x plus 1 minus 2 over 2x minus 1 dx. And also from the integration with natural logarithms. These were videos that I encourage you to check out. We are going to have 2x plus natural log of the modulus of x plus 1 minus natural log of the modulus of 2x minus 1, and keeping the limits. From there, we substitute the limits, starting with the upper limit, of course, and subtracting the lower limit. That is what we would get. And simplifying that, we would get 4 plus natural log of 3 minus natural log of 3 minus 2 plus natural log of 2 minus natural log of 1. And that would then simplify to 2 plus natural log of 2. Let's look at example 3. Show that the integral from 0 to half pi of cosine of x divided by 9 minus sine squared x dx is equals to 1 over 6 times the natural log of 2. The solution. Now, I encourage you to check out our integration by substitution videos, part 17 and part 18. Let's use the substitution u is equals to sine x, implying that our du dx is equal to cosine of x, implying that dx is equals to du over cos x. Now, considering the limits, x was half pi. Now, substituting it into our new variable, we are going to have u is equals to sine half pi is equals to 1. And x is equals to 0. U is equals to sine 0, which is equal to 0. Substituting for the dx, u, and the limits, we are going to have that, and simplifying further, because we can see that the cosine x will cancel out. We would then have the integral from 0 to 1 of 1 over 9 minus u squared du. And then from the quadratic factorization video, and I encourage you to check out the quadratic factorization video, we can break this one down, that's the denominator, into 3 plus u times 3 minus u. Now, considering the algebraic fraction that we have now, we can actually partition this using the partial fractions in the form 1 over 3 plus u times 3 minus u is equivalent to capital letter A divided by 3 plus u plus b divided by 3 minus u. Now clearing the fractions, we get 1 is equivalent to a times 3 minus u plus b times 3 plus u. And we label this one identity star. Eliminating a, we set u to be equal to 3 in star, implying that 1 is equal to 6b, then b is equal to 1 over 6. Now, we have the question and the key points on the left-hand side as usual. We have the identity star. We have also the partial fraction form, as well as the value of b of 1 over 6. Now, we move on to eliminate b since we have the value of b. We set u to be minus 3 in star. In doing so, we are going to have 1 is equal to 6a, implying that a is equal to 1 over 6. Therefore, that fraction can be partitioned or decomposed into being 1 over 6 times 3 plus u plus 1 over 6 times 3 minus u. Going back to the integral that we had, that we are trying to find and evaluate. So instead of having that fraction, we use the decomposed one. Now that we have this, we can factor out the 1 over 6 from the integral and integrate individually. Now, I encourage you to check out our integration video with the natural logarithms. So now this is what we have, 1 over 6 times natural log of 3 plus u minus natural log of 3 minus u, all evaluated from 0 to 1. The next step, of course, would be to substitute with the limits, starting with the upper limit, subtracting with what we would get when we substitute with the lower limit. So with that, we are going to get 1 over 6 times natural log of 4 minus the natural log of 2. That simplified would now mean that our question is equal to 1 over 6 times natural log of 2 according to the laws of logarithms. So that's how we would go about this kind of question. Let's look at question 4, the last question for the session. Show that the integral from 0 to natural log of 2 of e to the 2x divided by 1 plus e to the x times 2 times e to the x plus 1 dx is equal to 1/2 times natural log of 27 divided by 20. The solution. So using the substitution method, we are going to let u be equal to e of x, implying that the du dx is equal to e to the x, which means that our dx is equals to e to the minus x du. And we consider the limits since we're dealing with definite integrals here. So we had x being a natural log of 2, implying that u is equal to e to the natural log of 2, giving us a 2. That's for the upper limit. For the lower limit, we're going to have u is equal to e to the 0, and that is equal to 1. So our new limits are 1 and 2. Now, substituting into our original question, we are going to have the integral from 1 to 2 of u divided by 1 plus u times 2u plus 1 du. Now, we consider the fraction inside the integral. That is u over 1 plus u times 2u plus 1. This is equivalent to capital letter A divided by 1 plus u plus b divided by 2u plus 1. We are decomposing this because it would simplify our integration. So we clear the fractions, of course, so that we have u is equivalent to a times 2u plus 1 plus b times 1 plus u. We label this identity star. Now solving for a and b, we eliminate a first by setting u is equals to minus 1/2 in identity star. In so doing, we are going to have minus half is equal to b times 1 minus half, and that would give us b is equal to minus 1. Then we move on to eliminate b. Since we have the value of b, we set u to be equal to minus 1 in identity star. This would give us minus 1 is equal to a times 2 times minus 1 plus 1, giving us the value of a, which is just 1. Now, on the left-hand side, we have the question, the key points, the equation star, the b and the a, as well as the form of the partial fraction. So then it means that we can actually express the fraction that we were working on as being equivalent to 1 over 1 plus u minus 1 over 2u plus 1. That is after we have substituted for the values of a and b. This then implies that if we are integrating this particular question, we are actually using the partial fractions in simplifying our work so that we have that. And with that, recall from the videos that covered the integration with natural logarithms, we are going to have the natural log of modulus function 1 plus u minus 1 over 2 times the natural log of the modulus function of 2u plus 1, and this being evaluated from 1 to 2. Now we substitute from the upper limit to the lower limit and subtract the 2. That is what we would have. And simplifying further, we would have a natural log of 3 minus half natural log of 5, all subtracted with natural log of 2 minus 1 over 2, natural log of 3. So now we are going to have this as our answer for now. Natural log of 3 root 3 divided by 2 root 5. Now, take a look at this. We want to show that which is given, and we see that we can actually square what we have inside the natural log function and multiply by a half according to the laws of natural logs. And in so doing, we are going to have that bit there, and that gives us what we are looking for. So meaning that the integration of what we have on the left hand side is equal to 1/2 of the natural log of 27 divided by 20. If you have made it thus far, I say congratulations. I'll leave you with the following task. Show that the integral from 2 root 2 to 3 root 2 of x plus 3 root 2 divided by x squared minus 2 dx is equals to the natural log of 3. I encourage you to subscribe so that you don't miss out on any of our future uploads, and write in the section how you managed to solve this problem. Let me know of each and any problem that you might have encountered during the session or any other questions related to what we have covered. Thank you so much for watching Numbers Simplified.